So I'd like to welcome you to our talk about AI assistant modeling with Papyrus Web and SysOn, and also a bit with Capella. And the talk will be given together with my colleague Julie Bonnail and myself, Ansgar Radermacher. And we also used some material from our colleagues in our lab. So here a brief overview of the agenda, and we start with the motivation. Why do we need AI support for modeling? And well, as you all know, software development has become more and more complex. You have to deal with additional aspects like product reliability, functional safety, real-time certification issues, and as we had heard today, this morning, there's also the cyber safety, which is becoming more and more important. And you want to develop these systems with a mature process. So I have shown here a simplified diagram from Ebert et al. And so you need to support some methodologies to develop these systems. Since you're dealing with different concerns, you also want collaboration support, because there are different stakeholders that help you to develop these systems. And in order to all these requirements related to compliance, you need to have traceability. You have to make sure that your requirements are covered, that you demonstrate the conformity with regulations and automation maintenance. And for all these tasks, you want to have some suitable automation. And you can use model-driven engineering because it supports well these different concerns. You can have different models for these aspects. But in order to produce good models, this requires a lot of expertise, and therefore this automation is something which can really be useful. Also to get to become an expert in tool usage might be something which prevents people to use these tools. So how can AI help? And well, we are in our lab, we are doing applied research, and we are looking at the different ways how can AI support us to be integrated into the engineering processes, for which tasks, which artifacts within the models we can use that. And if we are having a complex system, for instance, in the software-defined vehicle domain, we have to deploy it on a hardware. We also need hardware models. And as I already said, there's this collaboration between different stakeholders to define such a complex system. And we can imagine that AI is also one of the participants that collaborate on a model. So which are the interaction mechanisms that we can use? And a very important question is, if we get some AI results, we have to evaluate them. We have to have confidence in them. And we have to have a suitable process to integrate these results and remain confident in the produced software systems. And one question that you might ask is, well, we have these powerful AI mechanisms, these everyday more powerful AI models. Couldn't I just take all my requirements, safety, security, and some design goals, and then with a very elaborated prompt ask my AI to generate the whole system? Well, you can do that. For simple systems, this might work. But we have these verification and analysis of if everything is really conformant with requirements. And this is just not realistic to do for a complex system, because you don't have any intermediate results. You have directly the executable and deployable code. And if you are not happy with the results, it's difficult to analyze. Then you can just refine your prompt, but it's difficult to obtain such a system and at the same time demonstrate the conformity with regulation. So instead we propose a model-driven engineering process, and well, this might look like a V process where the right hand is missing, but it's rather that we are proposing to integrate mechanisms like shift left and shift right, so that we have at each level here already some validation steps. So when we are looking at the requirements, we have some refinements of the requirements where AI can already help us. So we have the feedback and analysis on this level. We have the model-driven specification, functional specification, a design document, and then we can go to code generation and deployment. And at each level, we can have some DevOps that put tests in the loop, that put analysis tools in the loop. And by this way, with this iterative refinement, we will arrive to create a system that fulfills all the requirements and corresponds to regulation. And an AI coach can help in this process, automate some of the aspects, and thus help us create a good system. And by doing all these steps, we master the architecture. We have a separate intermediate design document for the architecture. We can run safety and security analysis on this, and we can run verification and validation on the immediate models. And this is a teaming up between human and AI. And we can have specialized agents for specific tasks, like completion and analysis. We also have, well, with respect to design knowledge, this can be covered by means of well-known architectures, well-known solutions, design patterns, and we have an ongoing PhD thesis to analyze this. And we can also generate test cases, as has been done in a project with a partner. So this is the basic process that we like to do, and we want to do that in the context of some modeling tools that we have developed. Initially, since the early 2010 years, there is an Eclipse-based project that is called Papyrus. So this was, or still is, a UML-based modeler for the Eclipse desktop. So it's based on open standards, the OMG standard UML, and it's highly customizable. It can be adapted to a specific domain. We can, for instance, with extensions, support code generation. There is a Papyrus software designer. There's also a Papyrus version for robotics. And this is an open source Eclipse-based tool, and you can download it at the web page here. Well, you see here some elements like the model explorer and diagrams, here in this case representing a state machine. And something which is very new is that we have started our migration of this tool to the web. So there is a Papyrus variant for the web. It's accessible in the browser, so it supports collaborative modeling. It's also configurable and extensible, and it's based on Serious Web collaboration that we have with Obeo. And here, the interaction with your team members can be done with Matrix Element. So it's another open source tool that we integrated into our solution. And here's another tool that is the result of a collaboration with Obeo. You see here SysOn, a SysML v2 based modeling tool that is based on the same technology as Papyrus Web, so on a series web from Obeo, and you can download it here. And yeah, probably I forgot to mention that my colleague is very proud of that. We have now a sandbox version of this Papyrus Web that you can directly try out or after the session to get your models. And with respect to AI integration, we first had the idea that if the user has some prompts to ask some queries about the model, then we pass by a small textual format of the UML model that we achieve with plant UML. And so whenever you post a question in the prompt, then implicitly this text version of the UML model was available, and you get a response related to that, but you then had to still integrate the responses from the model. And a new thing is that we now have an agent-based model that no longer relies on a textual representation of the model, but we are relying on a pilot module that is able to interact with the UML model. So it's an AI agent that is able to use an MCP protocol to interact the UML model. And it's piloted by an orchestrator that is called Numeribus, and all of this will be detailed later by my colleague.
The presentation of this AI assistant will be done in two parts. In the first part, I will show you the result of our research, the demonstration of Numeribus, as Ansgar mentioned. And in the second part, I will explain the different steps we worked on to get this result. So this is Papyrus Web with the semantic view, the graphical view, and the AI view called Numeribus. You first need to say to the AI where you're working on. So sorry, the presentation is in French. I will translate each part of this presentation if it loads.
Yeah, if it's not loading, we can run directly the downloaded. Yeah.
Okay, so I say I'm working on the Pipazza project because it's a pizzeria representation. And in the pizzeria document. The AI will be able to find this model and to describe it. So yeah, it found all of the classes, ingredient, client, command. But you can also ask the AI more details about this model. So what this model represents? This model represents gestion of a pizzeria with the client class contain properties like this. You can ask the AI to create new classes. Here I ask to add the class delivery. So it creates a class in the semantic view and in the graphical view. It calls the tool from Pypilot. I will describe this later. And you can also ask the AI to add multiply elements at the same time, like 3 new properties in this new class, like name, first name and address. You can ask the AI to delete the last changes. I made a mistake. Please delete last modifications. And here, the 3 new properties have been deleted. And you can also ask the AI to add links between classes. Here, add a link between pizza and ingredients, and it creates the link here.
F11. Oui, tu fais F11 pour... ouais.
Okay. So now on the architecture of this workflow, to be able to make the modification thanks to AI, we need to create an API. We call this API PyPilot because it pilots Papyrus. And this API is completely independent from Papyrus Web. It works on a completely different server. It can access models on projects, so it can retrieve all the components from this project. And it can modify the semantic and the graphical parts of the project in Papyrus Web. More than 30 different commands are available in Papyrus Web, in PyPilot, sorry. And this API acts as a GraphQL client connected to the model server and asks for queries, changes, or subscriptions. So we've got an API, but this API can be directly called by an LLM. We need to change this API to a MCP server. So that's the second version of PyPilot, which is PyPilot v2. And each of the REST API commands are now MCP tools. The PyPilot hosts the MCP server part, and it's accessible from an MCP client. And the MCP tools created by this MCP server are usable in any AI agent. I can show you a demonstration of PyPilot.
Yeah.
Yeah.
Double click. Doesn't work.
No. Okay. So on the left, we have the Papyrus web view, and in the right, we have Postman to see what the MCP server contains. Here we can see all of the MCP tools. So for example, get all projects. It will give as a result of the project in our Papyrus web session. And you can call each tools with this button. In this part, we do it manually without LLM for now. So when you run get all projects, you get a JSON with the name of the project, the ID of this project. And it acts directly on the Papyrus web on the left. We create a class. We will ask the MCP to rename this class. So you can use the MCP server manually.
Yeah.
The final step was to connect these tools to an agentic workflow. AI agents are LLMs model with access to tools. It allows them to reason and to act on the workspace. An agentic workflow is a sequence of specialized agents Here in our workspace, or on our workflow, we got two specialized agents, the planner and the executor. The planner will think about the sections of actions to call from the MCP tool. It analyzes the user queries, and such as create a new class or create a whole model to understand what it needs to do, and it generates a plan from this user query. The second agent is the executor. The agent has access to the plan from the planner and will execute the tools on Papyrus. And it answers the response. It answers the user query with a natural language response, or it can ask to more precision about the user query. For example, it will not create a class if it doesn't know what the class should represent. What technical stack we are using? The programming language is Python. We have created a web app with a Streamlit, a Python library, which easily transforms Python code to web app interfaces. For privacy issues, we are constrained to use LLM from the CEA, which is Codestral from Mistral. But the structure is made to be able to use any kind of LLMs, such as Claude or Gemini. The agents are created with LangChain. It's an open source library to structure the usage of AI agents. It helps with the use of prompt, tools, and memory for each agent. Our agent communicates through the A2A protocol from Google. The agents are coded in two different files, and you can choose your preferred language to code these agents. And even if they are not in the same language, they will be able to communicate together. And we give the agent access to the MCP tools, as I mentioned before. The architecture is standard and modular. So this first architecture is very basic, but in the future, we can add easily new agents, new specialized agents. I talk about human and agent collaboration, but the purpose of Papyrus Web is the human-human collaboration. So we integrate Numeribis, the agentic workflow, as a bot in Matrix Element. Ansgar talked about the Matrix as a collaborative chat for each project. So you can call the Numeribis bot in the chat. It will modify the model as requested. And every members of this chat have access to the user query and to the agent response. About next steps, because the new releases of Serious, the GraphQL schema called by PyPilot changes frequently. So now we need to adapt it manually at each new version. And for the next part of the project, we plan to automate the handling of Serious GraphQL to make this automatic, thanks to generative AI. Another project is to use specialized agent, as I mentioned before, for other projects. We can imagine adding a robotic specialized agent in the Papyrus for robotic, in Papyrus for robotic. And we can imagine also adding agent for the creating a documentation automatically with the model. And to extend human-machine interaction, we plan to add more possibilities to Numérebis, such as integrating a voice-to-text. It could be useful in a meeting to just ask Numérebis to add a component in a model, but it's also more inclusive. It's a more inclusive way to use Papyrus Web for people who don't have possibility to use a keyboard, for example.
Yeah, thank you, Julie. To address one of the problems that we had before, well, there is this worker that we have already shown with our agent-based approach. But at the beginning, I identified two issues. That was these modeling tools that we developed in the past are not very easy to use, so it requires a certain time to get familiar with these models. And then there's also some need for automation. So if I want to create a class with some members, there's a lot of clicks I have to do. And if I can just describe either orally with voice to text or with the keyboard, saying, okay, I want a class having these attributes, or in a certain domain, add me the standard attributes, then I can really profit from the automation. And these two goals, to simplify the tool usage and to guide and assist the user, is a goal that we share with Obeo, who is also developing modeling tools. So the idea was to combine the strengths of both partners, which are in model-driven engineering, the associated tools, the frameworks, notably Papyrus Web, and the methodologies like Arcadia, and then add the AI assistance to it to simplify the tool usage and to provide for automation. And we're doing that in several small projects, focusing on certain aspects, like my colleague will now show you.
This project on the joint laboratory, the first one is the intelligent onboarding assistant for MBC tools. The plan is that the AI agent provides interactive guidance, explanations, and suggestions when you load a project, and it should be tailored to the user models. The assistant is personalized based on the user profile, considering their experience, their job, and the context of the model. The output will not be the same for a novice student user than for a senior engineer, and it adapts to the user progress. Here is an example of how this onboarding agent works. In this demo, Alice creates a model. Here, it's blurry, but it's car modelization with a car, with the engine and seats, for example. She might leave this work for a while due to holidays or other projects. And when she returns, the onboarding agent provides her a summary of the project. The output may look like this. This project is about modeling a car. The central element is a car. And it presents the last update of this project. The last update is the addition of the braking system with the security requirements. As I mentioned, the output is tailored to the user profile. So if Bob, a new novice project member, joined the project, he will receive a totally different output. The output is much more detailed because Bob never saw the model before. So it describes each class, an engine, which is responsible for the powering, a passenger compartment. So it's the same subject, but it's much more detailed for Bob. Here is a toy example. It's a very simple model, but we can imagine how useful it could be when you join a very complex and dense project to have a summary of this project. Then, if Bob modifies the project, here we can see that Bob is adding an indicator. When Alice comes back to the project, she will receive a summary of the modification made by Bob. And here it's blurry too, but the AI output is, since your last connection yesterday, the user Bob has added a whipper and an indicator. This onboarding assistant is adapted on user profile. So Alice, as an expert, already know the project. She only needs a quick reminder. And Bob, as a new member of the project, requires a much more detailed summary. This onboarding agent simplifies and accelerates the integration process for new project members. And it helps users quickly get back on track after a break on the project, and enhances collaboration by summarizing the changes made by coworkers.
Yes, thank you, Julie. I'd like to come back to conclude our talk with some description of ongoing work. So we like to customize our approach for different domains. There is, for instance, a European project Astir, in which we apply these processes to the robotic domain. And we are also having projects in the context of software-defined vehicles and manufacturing. I will come back to these later. And we will then evaluate the trustworthiness of the AI assistance, which is very important because well, we are dealing with domains in which safety plays an important role, and if we blindly trust the AI agent, then we could have very problematic results. So one advantage is that we are already at a relatively high level of abstraction here in the modeling, so we can evaluate the intermediate results, but we can also imagine that we integrate some hallucination detection mechanisms on which my colleagues work, and that we can put well, stronger emphasis on the human in the loop. Other colleagues of mine are also working on the specification of the operational design domain, which is important in the automotive domain, so that we know under which condition a system is supposed to work. And if these conditions are not met, that we can automatically remind the user to specify some countermeasures for these edge cases. And well, in all the cases where we are using LLMs, we need good data sets. And for code, this is not a big problem. But for models, there are not many data sets with proven results. And something which is interesting that we are in a joint project called Code Commons with the Software Heritage Archive. So we have access to a huge amount of code and models, and we start to analyze them to get also better modeling results. And with respect to the integration of safety and security, we are collaborating in the SDV projects, HAL for SDV, Shift to SDV. For instance, the Technical University of Munich is creating test case scenarios based on AI assistance, and that is something that also the partner AVL is doing. And we have Andreas Eckel here in the audience, so the head of the HAL for SDV project. So AI is playing a certain role in these projects, and also modeling tools to have these intermediate results that you can evaluate. And well, there are other supporting projects. We already mentioned the joint lab and the Help for SDV projects, or Shift SDV projects, which are ChipsGU projects, and are maybe in the future the AI for SDV projects, and they are coordinated with an additional project called Federate. There is the STIA project in the robotics domain. There's Arrowhead Tools, another project focusing on tooling, specifically in the AI context. And there's Code Commons, where you get access to the software heritage archive. And France is also supporting these aspects. There's LLMs for EU initiative. I think I will quickly skip some of the publications we have done. Well, there is some work on design patterns, some work on agentic AI, but I think you will get access to the slides later and then see these aspects. So thank you very much for attending today, and you can ask questions now, and you can also visit us later at the booth number 6, here depicted on the slide. And yeah, thank you for your attention.
Hi, thank you for the presentation. I noticed that you guys said that you had already a REST API, but you took the time to translate everything to MCP tools.
Right. Yeah.
What was the motive behind that, and probably some improvement, right?
Yeah, the motive, well, my colleague can also answer. The motive is that if you have an AI agent, it's easier to integrate it with an MCP protocol than directly the REST API.
Yes.
Yeah.
Okay, well, was there any performance gain or cheaper to use because of the tokens usage that reduced or something? Or?
Yeah, well, it was just it's just not directly possible, I think, to call a REST API from an AI agent. Or do you have some complementary information on that, Julie?
It's just easier to use MCP tools, and the agents can understand more easily MCP tool than how to make a request to an API.
There's a standardized way to describe the API, what it supports if you use MCP. So it was more native way to do it. Yeah.
Okay, you're right. I mean, MCP describes that you have to say what the method does and what the parameters mean. So that alone is improvement. Thank you.
Thank you.
Other questions? Okay then. Thank you, and visit us at the booth.
Thank you.